Okay, next we are going to start with an in-class problem. So we have a large grinding wheel is attached to a motor. The motor is initially spinning at 1750 RPM. The motor is turned off and the angular acceleration is known to have a magnitude of 1 radians per second square. Determine the following. First of all, how many turns the wheel make in the first 10 seconds after being turned off. And next one is going to be the angular velocity of the wheel in RPM at a time of 20 seconds. And next, time required for the wheel to stop spinning. And the last, the number of revolutions the wheel will turn during the time it takes to stop completely. Okay, so I would suggest try to do it your own, as I mentioned before. Hopefully you checked the review, and we did a problem yesterday, last time on Monday class, and try to find it yourself and then check the answer. No, don't look at the solution, but just look at the answer first, and then if it is wrong, then either watch the video or look at the solution on the PDF. Okay, so there are a couple tricky things here, and so we need to make sure we understand what they are. Okay, first of all, initial velocity and its angular velocity is given, right? And the motor, there's an acceleration which is 1 radians per second square, but the motor is turned off, so it is slowing down. Okay, so if you choose the velocity, the angular velocity to be positive, and we can just always say again, the direction of the rotation we can choose. If we choose this velocity to be positive, the acceleration is going to be negative because it's slowing down. They are not telling us, so it just says the magnitude, but we need to consider the directions as well. Okay, so don't skip that, because if you do, then you're going to get it wrong. And the other things are the units. So it's given as RPM. And the acceleration is given in SI units. So you cannot use them in the same equation. You have to convert them. And the first one is asking for how many turns the wheel make. What is it even asking? Do you understand that? Can you figure out what are you looking for? Okay, is it theta? Is it omega? Is it alpha? Is it the time? Is it initial or final? So what is it? It's asking for how many turns, and that is related to the angular displacement, but not in radians, right? It's really asking for how many revolutions you will have. So we need to kind of think about converting it later as well, and it's only asking for the first 10 seconds, so we need to be very consistent with our solution. So let's look at the first part. So we are going to assume that we are choosing the omega to be positive, and but we remember that it is slowing down. So if you choose omega to be positive, then the acceleration should be taken as negative, because slowing down means they won't match, right? So you should take opposite directions, and so you kind of need to really just see that. And then the first step is writing the two equations, constant acceleration, motion, right? So we have the position equation, angular position, and the angular velocity. We have those two equations here, because again, the acceleration is constant, right? This is the reason we can use these. And now this is our step 1. And now step 2 is writing at the start and at the end. So at the start, the omega 0 is given, but it's given in RPM. And since you need to use the acceleration in radians per second square, you cannot use RPM for omega 0. So you have to convert them, okay? Let's use SI units. So what we need to do, let's convert this RPM to radians per second. How do we do that? We got to get rid of minutes. So 1 minute is 60 seconds. We also need to get rid of revolution and then make it radians. And these are the conversion factors that we multiplied. And each of these are simply 1, right? So it doesn't really change that when you multiply with the 1750 revolutions per minute. but we are getting rid of the units that we didn't want, and then we are getting the SI units this way. So 1750 RPM is 183.26 radians per second. Okay, and at the start we can also take theta 0 to be 0, and at the end, so you are also assuming at the start t is equal to 0, but at the end we are saying that it's been 10 seconds, and the important thing is here acceleration. It should be taken negative again because it's slowing down, because then we are saying omega 0 is positive, so that alpha needs to be taken negative. Okay, that's important. Next step 3, is plug those in. And again, so if you look back, let's just do one more thing and get rid of the stuff that are 0. So theta 0 is 0, right? And what else do we have? Omega 0 is going to stay there. Nothing else that I can see is 0. So we're just going to get rid of theta 0. And I'm using that equation. Theta 0 is gone. And using the SI units, carrying the units out, please make sure to do that. This is very crucial, and you will make a lot of mistakes if you don't do that. Hopefully it's a habit now that you do it anyways. But so plug the numbers in. Again, that acceleration was negative, so we have that negative sign in the front. And checking the units, you will get radians as the unit, like seconds, and second squares will go away. But the problem is they're not asking in radians, right? They're asking for how many turns does it make. So you need to look at the revolution. So you need to use that conversion again. Okay, so 1 revolution is 2 pi radians, so these radians will go away, and then you're gonna get revolution as like number of turns, and this is how many turns you have. So make sure to check what is it asking for in terms of units. So you'll get SI units probably, but then don't forget to convert it whatever they're asking for. So this is part A, and part B is let's go back to problem. The angular velocity of the wheel in RPM at a time of 20 seconds now, not 30, not 10. So let's find that out. We are starting with the second equation, velocity equation, and again we are using the SI units for omega 0, as you can see it here. And that negative sign again for the acceleration, alpha times t, but we're using 20 seconds for time. And checking your units, you should get radians per second because that's what omega is in SI units. However, they're asking us to find it in RPM. So you need to do conversions again. Okay, very common conversions in this chapter. Get rid of seconds, and radians should be also gotten rid of. And you're gonna get revolutions per minute. It's RPM. At the end, doing this simple algebra will get you there. And double check your answer. Doesn't make sense. We had 1700. What was the number? Was it 1750? Yeah, 1750 RPM initially. After 20 seconds, I expect omega to be less, and it is less than 1750 RPM. That makes sense, right? Okay, and we're going to do the next 2 parts in the next video.